Today we're going to be starting to talk about transformations. And the first kind of transformation we're going to talk about are what we call translations. Now, when we're talking about translations, it's like we're taking a whole figure and moving it. Everything stays the same. So we can talk about translating this eraser, going from here to here to here to here. Everything stays the same with this eraser. The size, the shape, the angles, everything stays the same. We're looking to do that with every part of what we have. Now, when we're talking about this, there's a few definitions here about what we're going to be using. The first one being a vector. Now, this has a quantity that has both direction and magnitude, which is also size or how long something is. We can just differentiate that vector with something like this, where if we have 3 comma -2, this is saying we're going to move this 3 spaces to the right and 2 spaces down. So the point here, we go from here to here in our coordinate plane. So all of these are kind of rigid motions, either going left, right, which is our x value, or up and down being our y value. And that whole thing will move. Initial point where we start, terminal point where we end, and this is what we call the translation. Every point of the figure has the same direction and same distance, which means the figure does not change, it just moves. So this is how it would look in a coordinate plane. So we're talking about these vertices of this triangle ABC. My axis there, my x and my y. I start by plotting 0, 3. Marking off an A. 2, 4. There's B. And 1, 0 being figure C. We have this triangle, this figure. We now want to translate this triangle ABC using the vector 5 and -1. So what this means is we're going to move it 5 to the right and 1 unit down. And it's every vertex we see. So a triangle has 3 vertices. We're going to be moving all 3 of these points. So we'll start with A. We're going to move this 5, 1, 2, 3, 4, 5, and 1 down. We move B, 5 and 1 down. 1, 2, 3, 4, 5, and 1 down. And C, 1, 0, moving 1, 2, 3, 4, 5, and 1 down. As you can see, we have the same exact figure. Now, how we name this is a little bit new. We're still going to call this point that we moved over to here A. We're going to call it A prime with a little slash up here. This thing that we moved B to here, we're going to call this B prime. And this one from C going here is C prime. So the initial figures marked with just the letters. The terminal spots are labeled with the letters and a prime by it, so we can see that it moved in that direction. And as you can see, you don't have to do this when we ask you to do this for an assignment, but we can see with my blue dashes, everything's moving in the same direction and with the same size, which keeps my figure the same. Next problem. Now we're doing a quadrilateral. So we start by naming our points. I fix my XY. So we have point A being -2, 4. 1, 2, 3, 4. So there's point A. Point B, -5, -1, -0 with -7, here, and then 3, 6. and there's D. And we have that figure there. Please assume that this is a straight line. Now it says we're using a vector of 4, 2. Here's my vector. Now my vector, both are positive, so I'm going to go to the right 4, and I'm going to go up 2 with every single one of my points. So here is prime. B prime. C prime. And D prime. And you can see we have the same shape here as we translated over here. So at this point, we're counting numbers. Not too much calculation going on. Now we're going to go in the other direction. We are starting with this figure here. Here we have P, Q, R. And it's translated going from here, going back towards this red triangle. Now, what we're looking to do is to see how many we're moving left and right first. We can see that we're moving to the left. So we're going 1, 2, 3, 4, 5, 6, 7, 8 to the left. And we're going up 2. That becomes P prime. For Q, we're moving again 8. Coming over to here, we're going up 2. Here's Q prime. Same thing with R. We're moving 8 to the right and up 2 to get to here. And here is R prime. So we can look to see how far we're moving left and right. And that would be kind of like our vector. So this is how we're going to write this with a vector. Now, if we want to come up with a certain rule, because these are x's and this is y's, we can also list this as x minus 8 and y plus 2 as our answer. This is what's going on here. We're moving this thing 8 units to the left, 2 units up. So we can show this using a vector or with kind of like an equation here. Here's a second one. Here's our original one. So now we're moving the blue one to the red one. And you can see we have these same shapes. So we can see that we're moving this 1, 2, 3 units this way. And we're moving 1 unit down. So we're moving that 3, that down 1. Heartbeat, we're moving 1, 2, 3, 1 unit down. C, 1, 2, 3, 1 unit down, 1, 2, 3, 1 unit down. So our vector going from here to here would be 3, negative 1. If we want to write that with an equation, we'd write this as x plus 3, comma, y minus 1. And that can explain it both with vectors and with equations. So again, we're looking to count. The shapes remain the same, the angles remain the same, everything remains the same. The only thing we're doing is just moving it. So come up with this definition of rigid motion. Rigid motion is a transformation that preserves length and angle measure. Another name for rigid motion is an isometry. And kind of like a new fun word to say, isometry. A rigid motion maps lines to lines, rays to rays, and segments to segments. So again, everything stays the same. And that's exactly what we just did. Now the last thing here, we can complete what we call a composition of translations. What a composition is just a series or a group of translations, multiple than just one. So here, we're starting with these endpoints, and here's my y, there's my x. So we're starting at -8, 5. And then we're going down 5, or up 5. So here's R. Now S is -6, up 8. So we have this segment. But we have two translations, our composition. So we have two steps of this. The first one, we're going to go +5 with the x and y -2. So we're going to go 5 to the right, 2 down. 1, 2, 3, 4, 5, 1, 2. Here's my new r. 1, 2, 3, 4, 5, down 2. Here is my s prime right here. It's the same length, it's at the same angle, everything stays the same. But that's only half of it. We now want to do another one where we move to the right or to the left 4 and down 2 again. So this time we're going to go right 4. 1, 2, 3, 4, and down 2. This becomes our double prime because that's our second motion. S, the same thing. 1, 2, 3, 4 to the left, down 2, and this becomes S, double prime. And that's our terminal motion there. So first we went right down and then back left down. As you can see, these are all the same. We have just moved them. Kind of just like moving the marker here to here to here, using these different kind of motions. And that concludes this lesson.